Okay, a marketing research firm wishes to study the relationship between wine consumption and whether a person likes to watch professional tennis on television. 100 randomly selected people are asked whether they drink wine and whether they watch tennis. The following results are obtained. And the question is, test the hypothesis that drinking wine is independent of watching professional tennis. So I'm going to assume that they are independent. So I'll say H sub 0 is drinking wine is independent of watching tennis. And the alternative, I'll just say not independent. Now I want to get my collected observed frequencies and put them into a table. Okay, and I've also included the totals in the table and my formula for calculating the expected frequencies. I have the observed frequencies, the 16, 24, 4, and 56, but I need the expected frequencies. So in exactly the same way that I was performing these calculations when we were doing the test of equality, I'm going to do the same here for the expected frequencies. I'm going to take 16 and notice that it is in row 1, column 1, so the row 1 total is 40, the column 1 total is 20, and divided by the sample size total of 100. So that turns out to be 8. Now just to stop here for a minute and ask ourselves why that makes sense. Now the null hypothesis we're assuming to be true, and it's saying that drinking wine is independent of watching tennis. In other words, for people that watch tennis, the percentage who drink wine is the same for the people who don't watch tennis. In other words, tennis doesn't tend to influence whether a person drinks wine or not, and drinking wine doesn't tend to influence whether they're going to watch tennis or not. So in other words, we're assuming they're independent. There is no real connection between the two. One doesn't really influence the other. And when we build our expected frequencies, we're assuming that the null is true. And on this first frequency, we realize that out of 100, 20 of those people said they watched tennis. Well, if there is really no connection between drinking wine and watching tennis, then that same percentage we should be taking out of the 40 total that drink wine. In other words, if 20% of the people said they watch tennis, then we'll take 20% of the 40 total that drink wine between the two groups, and that's what we would expect if there is no connection between drinking wine and watching tennis. Now let's go to our observed frequency 24, and that is in the first row, second column. So I'm going to take 40 times 80 divided by 100 and get 32 as my expected frequency. So 80%, again this makes sense, 80% of the total people surveyed said they don't watch tennis. So we would expect that 80% of the 40 people that drink wine are people who don't watch tennis. So out of 100, 20% watch tennis, 80% don't. So out of the 40 total that drink wine, 20% of them watch tennis, which is 8, and 80% of them don't watch tennis, 32. Okay, let's keep going here. I'm now down to frequency 4. And that is in row 2, column 1. So I will take the total in row 2, which is 60, times the total in column 1 and divided by 100, and I get that's equal to 12. And then lastly, 56 is in row 2, column 2. So the row 2 total, 60, times the column 2 total, 80, divided by 100. And we get a total of 48. Now we are ready to go ahead and calculate our test statistic, which is chi-squared, and run our test. Here is our chi-squared formula, and notice again it takes the difference between the observed frequencies and the corresponding expected frequencies, squares those, divided by the expected frequency, and it does it across the rows and columns. So I'm going to have 4 calculations here, and I'm going to start up with the first category, drinking wine and watching tennis. The observed frequency is 16. Subtract the expected frequency, square that, divided by the expected frequency. And then going to the next one, I have 24 subtract 32 square divided by the 32. And then I have 4 subtract 12 square divided by 12. And 56 subtract 48 square divided by 48. And I get that equal to 16.67. That is my chi-squared value. That is my test statistic. And I want to use it to run the test. Now, what we need to do is to get the degrees of freedom on this. And the degrees of freedom for a test of independence is the number of rows, subtract 1, times the number of columns, subtract 1. So for us, that is 2 subtract 1 times 2 subtract 1, which is equal to 1. So 1 degree of freedom, and we are using alpha 0.05. So I'm going to kind of rough sketch my chi-squared distribution here. Alpha 0.05. We need a critical value. And in our table, at the 0.05 area in the upper tail and 1 degree of freedom, I get 3.841. So I want to compare that to my test statistic of 16.67, and I can see that 16.67 has got to be way out there. So that is very contrary to what we would have expected, given that, say, the null was true. And so I'm pretty confident that we can go ahead and reject H sub 0 since our test statistic, 16.67, is greater than 3.841. And I can also see that if I try to run this with a p-value, 16.67, in the row 1 degrees of freedom, 16.67 is much larger than 7.879. So my p-value, according to the table, has got to be less than 0.005. Now, if I run this in Excel, I actually get something that looks like this, 4.4 0.4557, and then I get a little e there, exponential with a negative 5. That just simply means 4.4557 times 10 to the negative 5, which is 0.123444557. In other words, that is very small, which we would expect with such a large test statistic that we did get. So again, we conclude the same thing, reject 8 sub 0. Now, what does this say? This says that they are not independent. So I can conclude that drinking wine and watching tennis are not independent. Now that's interesting. I wouldn't have thought that, looking at the problem at first, that there would be a connection. In other words, I wouldn't think that watching tennis would have some influence on a person drinking wine, or maybe drinking wine would cause someone to want to watch tennis more. No, there is a connection, but it's not like that. It's probably people who watch tennis are in social groups that it's cultural or whatever for them to be more apt to drink wine in those groups. Maybe tennis parties or whatever. That's just a favorite drink among people that get together and are like tennis somehow. I don't know, but the statistics does say that there is a connection somewhere, and that we can speculate on what that connection might be. If we're interested in drawing some conclusion, we'll just have to study the issue further and see what we can find.